Hello and welcome. In this video, we will be learning about the vector components. Suppose we have three vectors, vector A, vector B and vector C. Okay? And now what we have a relation between these three vectors, which is if we do A plus B vector, we will get the C vector. Right? So this C vector is called the resultant, right? Resultant vector. Okay, but what about these A and B vectors? These two vectors are called the components of vector C. Okay, so these are the two components that the vector C has. So if these are the only components of the vector C, no, it is not, because if I have vector A in this way and vector B in this way, and we will get the vector C almost in that direction. It is not 100% accurate representation, but this is like close to reality. Okay, so this is the thing. Okay, so now what is happening, that we know that A vector plus B vector equals to C vector, so we are calling A vector and B vector the components of the vector C. But if we want to construct this C vector, we can do this without this A and B vector as well. Suppose we have another vector P and another vector Q. Okay, and here is also P vector plus Q vector equals to C vector. Here is the C vector. So again, what we can see that this A and B vector are the components of the C vector, as well as this P and Q vectors are the components of the C vector as well. So why we need that? So why should we care? Because if we want a this is a Cartesian coordinate system, it is x-axis and this is y-axis, and if we want to construct a vector in this Cartesian coordinate system, suppose the vector is this one. Okay, this is a vector which is, suppose it is r. So then what we have to do to represent this vector in this Cartesian coordinate system? If we can calculate the x component and the y component of this r vector, then we can do like that. Like if this r vector has the component in the x direction which is rx, and in the y direction which is ry. Okay, so then we can write that this r vector equals to rx I cap plus ry j cap. If it is the three dimension, then we simply have plus rz k cap. It is very simple, and that's why we need to know about the components of the vector, because by the components representation we can construct a vector and we can represent a vector in the Cartesian coordinate system or in any kind of coordinate system. Just if we have the proper components along the axis, then we can construct the vector and we can represent it according to. Okay, that's it for this video.